All right, I'm going to be working through the practice test here. Um, so some things to note for the test. Make sure you do not simplify the answers unless you're explicitly asked to do so. That makes it a lot easier for me to check. And that way you also don't have to worry about how large the numbers are. All right, question one, find the formula for the nth term of the sequence. First, um, we want to think about what the difference is between the terms and also what the starting term is, right? So if you might recall, the formula we have is an equals a1 plus, what is it? N minus 1 times d, right? The idea is to go from a1 to an. That means we're adding d n minus 1 times. So in this case, a1 is 9. a1 is 9 because that's the first term, and d is going to be equal to -4. So that would be our equation. And I'm totally fine with you leaving it like this. We could have also simplified this to be 13 minus 4n. Okay. Next question, we have a summation of an arithmetic sequence. We know it's an arithmetic sequence because we have a linear term there in the inside the sum. So remember the formula. We're trying to find the average of the first and the last term, and then multiply by the total number of terms. All right, so the first term, sorry, I don't know why I'm having allergies. It's so early. Okay, the first term, to get the first term, we're going to plug in the first index, which is n equals 3. So that means the first term is -3 times 3 plus 1, which is -8. Last term is -3 times 14 plus 1, which is -41. Okay, what's the number of terms? The number of terms is 14 minus 3 plus 1, right? Not 11, but actually 12. So that means our answer is going to be the average of the first and last terms. -8 minus 41 divided by 2 times the number of terms, which is 12. So we have to simplify this, don't we? So that's going to come out to -49 times 6, which is -200, geez, -294. I'm pretty rusty at mental math these days. Next question, we have a summation of a geometric sequence. So let's recall the formula a times 1 minus r to the n over 1 minus r, where a is the first term, and r is the ratio, and n is the number of terms. All right, so here, the first term is going to be equal to, right, we just plug in n equals 2, so we'll have 1 over 2 to the power of 2 minus 2. That's 1, could be 1. The ratio is 1/2 because that's how much each successive term is being multiplied by. And finally, n, right, n is not maybe not the best variable to use because it's being repeated as the index, but that's fine. N is the number of terms, so that's 10 minus 2 plus 1, which is 9. So we have 9 terms in total. So my sum is going to be equal to 1 times 1 minus 1/2 to the ninth divided by 1 minus 1/2. All right, so that's going to be 1 minus 1 over 512 divided by 1 minus 1/2. which is equal to 511 over 512 divided by 1/2, which is equal to 511 divided by 256. Next question is very similar. In this case, the first term is also going to be 1. We just plug in n equals 0. The ratio is 1/3. And n, which is the number of terms, is going to be 5. 4 minus 0 plus 1. The denominator is 1 minus 1/3. So this is going to come out to 1 minus 1 over 3 to the 5th is 243 over 1 minus 1/3. So that is going to be 242 over 243 divided by 2/3, which is also multiplied by 3/2. So that'll be 121 over 81. Question 5. In this case, we have a infinite geometric series, so that actually makes things easier, doesn't it? Our formula will be a over 1 minus r. So here the first term is going to be actually 1 over 10 cubed. And r is 1 over 10. Sorry, that means the denominators, yeah, r is 1 over 10, so the denominator is 1 minus 1 over 10. So this is equal to 1 over 1,000 times dividing by 9/10, so that's multiplied by 10 over 9. And we'd be left with 1 over 900. That's pretty neat. Question 6, simplifying this binomial. Hopefully this is not too large. Okay, so we have a 5 on the bottom, so that means we want to take the first 5 terms from 16 factorial. So that's my little trick, right? 16, 15, 14, 13, 12 over 5, 4, 3, 2. So remember, my rule for you guys, always cancel before you do any multiplying. Save a lot of times. 5 and 3 cancels with 15. 4 and 2 cancels with 16 and leaves me with a 2. Um, okay, that's not horrible to multiply. Still not pleasant, but okay, 14 times 13 is 100. Oh my gosh, 182? I think 182. Yeah, 182 times 24, I guess. 8, 2, 7, 4, 6, 3. It's going to be 4, 2, 6, 8. Check with my computer. Oh dear. Oh dear. Oh dear. Nobody saw that. They're going to send me back to elementary school at this point. Question 7, expand and simplify. This is binomial theorem. Um, so remember the exponent, 6, that'll determine our binomial coefficients. So let me write it all out. First, we start with 6 choose 0, and the x term, or what, at least what comes first, is going to be to the 6th power, while the negative y will be to the 0 power. Oh my gosh, am I going to have to write out all 7 of these? Who's writing these stupid questions anyways? I think this looks right, so I'm gonna continue and simplify everything. 6 choose 0 is 1. 6 choose 1 is 6. 6 choose 2 is 15. 16x squared. 16x to the 4. Y squared. 6 choose 3 is, what is that? 20? 6 choose 4 is 6 choose 2, which is also just, what, 15, right? 6 choose 5 is 6. 6 choose 6 is 1. So my final answer is going to be 64x to the 6th minus 192x5y. I'd be quite happy if this was right. Good. Oh, shoot, 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 shoot. Not correct. That was bad. Next one. Okay, this one's a little easier, right? Only 4 terms in total. Question 9. Let's figure out how many nine-digit numbers are divisible by 5 if digits are not repeated. So we have 9 digits. So I always want to start with the digit that's most restricted, so that's the last one. In order for it to be divisible by 5, it must be either 0 or 5, right? So that means we have two total choices for the last digit. Now let's go all the way back to the starting digit, maybe. I mean, you could do the second to last, but I'll just start with the starting digit. Oh, I should clarify this actually. I should clarify this and say whether the leading digit is non-zero or not. Okay, I'm going to revise this. I'm going to revise this and say leading digit non-zero. Okay, so look out for that revision. Okay, so the next most restrictive one is, oh shoot, this is a problematic question now. Because if the last digit is 0, then there would be 9 choices here. But if the last digit is 5, then there are only going to be 8 choices for the first one. Okay, that means I'm going to revise it to say the leading digit can be 0. The leading digit can be 0. Okay, so that means that once I've chosen my last digit to be either 0 or 5, the first digit could be anywhere from 0 to 9, except whatever I chose for the last one. Okay, so that means I only have 9 choices. And then, right, I can't repeat the first digit for the second digit. So that means I have 8, 7, 6, 5, 4, 3, and then I have 2 choices for the very last digit. All right, so if I multiply all of this, this is going to come out to 2 times 9 factorial. Should use black. Okay, question 10. A group of 10 friends is going out to eat at a Chinese restaurant, and they sit down to eat at a circular table. However, Abby and Brian are dating, so they want to sit next to each other. All right, how many ways can the friends all sit down? So we're going to keep in mind that because they're at a circular table, arrangements separated by rotation are considered to be identical. All right, so that means similar to what we saw in the classwork, ABCD is the same arrangement as DABC because they're separated by 90-degree rotation. So we're going to have to think about some overcounting later. All right, so how should I do this question? Let me first draw the table. So I have this table. Let's put spot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are all my chairs. So Abby and Brian are dating, so that means they want to sit next to each other. So let me first think about how I can place them, and then I'll think about everybody else, right? That's kind of the idea. Similar to the digits, we want to start with the things that are most restrictive. So in this case, let me first put down Abby. Okay, I have 10 choices for where I can put down Abby. Um, so I'll multiply my final answer by 10. But let's just say I'm putting her here. Okay. So let me remind myself. 10 choices, 10 possibilities for where Abby can sit. All right. Now Brian has to sit next to Abby. So that means Brian only has two choices. He can either sit here or he can sit there. Let's say he sits there here, but let me remember that there are two possible choices to place Brian once Abby has been seated. Right? And then once I've seated Abby and Brian, I can go ahead and seat all other eight friends. So I'll have eight choices of who to sit here, seven choices for who to sit there, and five, four, three, two, one. So that means I have 8 factorial possibilities to place the rest. So in total, I'm going to have 10 times 2 times 8 factorial divided by 10. The reason I'm dividing by 10 is because I'm overcounting rotations. Okay. That's because if I'm rotating them clockwise or counterclockwise, it's going to be the same exact arrangement, just separated by rotation. So my answer is going to be 2 times 8 factorial. Okay. So that's one way to do it. That's probably the most straightforward. But there's actually another way, and I won't do it, but I'll kind of hint you towards how you might do it. The way to do it is by considering Abby and Brian to be a single person, and then rewriting this question as a group of 9 friends going out to eat at a Chinese restaurant. So treat Abby and Brian as a single person, and then think about the question for 9 friends. And then at the end, you have to multiply by 2 because Abby and Brian can either be Abby Brian or Brian Abby. And so you're going to get the same answer that way, 2 times 8 factorial. So think about it. See if that makes sense to you. Question 11. How many unique ways can the letters in Redeemer be ordered? All right. That's the name of my church, Redeemer. So Redeemer has how many letters? 1, 2, 3, 4, 5, 6, 7, 8 letters. Very good. So I have 8 letters. So that means I can order them in 8 factorial ways, but I'm going to overcount, right? Because I have some repeated letters. I have E being repeated 4 times, so I'll overcount by 4 factorial in the E's. And then R is repeated twice, so I'll overcount by another 2 factorial. So that'll be my answer. Question 12. In a class of 12 students containing 6 boys and 6 girls, how many groups of 4 containing 2 boys and 2 girls be formed? All right, so this is a more tricky counting question. Um, and we need to remember that the order does not matter within the groups. So let me first think about how I can choose the boys, and then I'll think about how many ways there are to choose the girls. And then my final answer should just be the product of that. I can think about it kind of in my 2 buckets. I have my boy bucket, and I have my girl bucket. How many ways are there to choose the 2 boys? Well, I'm choosing out of 6 boys, I'm trying to choose 2 boys. So that's 6 choose 2. How many ways are there to choose the girl? Once again, 6 choose 2. And so that's my answer. It's that simple. 6 choose 2 squared. Now you don't need to simplify that, but of course that's 225, right? This is also probably pretty easy to calculate. 8765 divided by 2. That's what? 420? Uh-huh. Just kidding. No, actually not 420, isn't it? It's a bit bigger. Just kidding. 840. Okay, question 13. A coach needs to select a five-person A team and a five-person B team from 15 players at a tryout. The remaining eight players will be cut. Oh no, too bad for them. How many ways can he select the teams? So, very similar to the previous question. Let's first think about how this coach can select the A team, and then how he selects the B team. And then, of course, the remainder are just cut, so we don't care about them. Well, we care about them, but we don't really care about them. So, how many ways can he choose the A team? He's choosing five people out of 18 players, right? So it's going to be 18 choose five. Now, how many ways, once he has chosen the A team, how many ways are there to choose the B team? Well, we only have 13 players left, right? So we'll have 13 ways to choose them. And then we're trying to choose five people from there. And then the remainder that you can just think about that as eight choose eight, right? But that's just one, so it doesn't matter. There's only one way to choose the remaining because that's all they have left. So my answer is going to be 18 choose 5 times 13 choose 5. All right, you could have also done these questions in a different way. Um, you could have done it this way. You could have said, how many ways are there to choose the first boy? There are 6 ways to choose the first boy, 5 ways to choose the second boy, 6 ways to choose the first girl, and then 5 for the second girl. Um, but this is a little more subtle because you have to account for the overcounting, right? You're going to overcount because the order of the boys and the order of the girls does not matter. But this is the same answer, isn't it? Similarly for here, although it's a bit more tedious to write, you could have done 18, 17, 16, 15, 14, 13, 12, 11, 10, 9. And then you're going to overcount because the order of the team doesn't matter, right? So you'll overcount the order of the A team, and you'll also overcount the order of the B team. But this gives the exact same answer. So those are two different ways of thinking about it. All right. Question 14. How many four-card hands have no repeating suits? Let's try to construct the hand. For the first card, you can choose anything. For the second card, we have to choose something from a different suit. So that means we have 3 suits left to choose from, and each suit has 13 ranks. That means we have 39 choices. And then for the second, we're going to have 26 choices. And finally, for the fourth one, we'll have 13 choices. Of course, we'll overcount by how much? 4 factorial, because the order of the hand doesn't matter. So the answer is 52 times 36 times 39 times 26 times 13 divided by 4 factorial. Now, if you look carefully, you would be able to see that this is actually equal to 13 to the 4th power. Now, why is that? You can think about counting this a different way. Think about the 4 cards, but in order for a 4-card hand to have no repeating suits, every card has to be a distinct suit, one of the 4 suits. So we can just go ahead and assign what the suits are based on the first, second, third, and fourth cards. We can say this one's clubs, this one's diamonds, this one hearts, this one's spades. And then we can go ahead and choose which card is a club and which card is a diamond. And we're going to have 13 choices for each one. We'll have 13 choices to choose the club, 13 choices to choose the diamond, 13 and then 13. So that gives us the same answer. Isn't this cool how we can get to the same answer through so many different ways of thinking? Next question. How many 6-card hands have a 4 of a kind and a pair? Let's say that the four of a kind is here and my pair is here. So I'm going to determine it to be like that. I have 52 choices for the first card. And then once I've set the rank on my four of a kind, I'll have three choices for the second, two for the third, one for the fourth. And then I'm gonna try and choose one for the pair. I'll have 48 choices for what that will be. Well, I only have 48 cards left. And then I'll finally have three choices for the last card to match the rank on that pair. How much will I overcount by? I'll overcount the order of the four of a kind, which is 4 factorial, and I'll overcount the order of the pair. I have 52 times 3 times 2 times 48 times 3 divided by 4 factorial 2 factorial. If I draw 4 cards at random without replacement, what is the probability of getting a 3 of a kind? Oh, jeez. What is the probability of getting a 3 of a kind? Um, okay, so I have 3 cards of one rank and 1 card of another, right? Because I have 4 cards in the hand. So for this question, you have to do it by first determining the number of desired hands over the number of possible hands. You can't do it the other way by multiplying probabilities. All right. So let me write down. These are my desired. I'm going to say that the 3 of a kind is going to be in the first 3. So I'll have 52 choices here, and then 3 choices, and then 2 choices, and then 48 choices for the fourth card, because it has to be a different rank. And I'm also going to overcount here by 3 factorial. Let me also think about the total possible. It's a 4 card hand. And it could be anything because I'm thinking about all the possibilities. So 52, 51, 50, 49. I'll overcount by 4 factorial. So my total will be 52 times 3 times 2 times 48 divided by 3 factorial divided by 52, 51, 50, 49 divided by 4 factorial. All right, if I draw 5 cards at random without replacement, what is the probability of getting a straight flush? I think I might have talked about this in class. There are 10 total straights because they go from ace to 10. And then for each straight, there are 4 straight flushes. We could choose between any suit, clubs, diamonds, hearts, spade. So there are 40 total straight flushes, and that's out of how many possible hands? 52, 51, 50, 49, 48 over 5 factorial. So that is a very slim probability. If you draw 3 cards at random without replacement, what is the probability that each card has a different rank and a different suit? This one I'll do the simpler way because we can. So for the first card, it could be anything. For the second card, I want to make sure I have a different rank and a different suit. Now there are 12 ranks left and 3 suits left. So that leaves me with 36 cards to choose from out of 51 cards in the deck. The third card, I have 11 ranks left and 2 suits left. So that leaves me with 22 cards in a 50 card deck. So that's my answer. 36 over 51 times 22 over 50. Question 19. I flip a coin 10 times. Calculate the probability of getting at least two heads. So this is something I want to do with complementary counting, because this will be very hard if I did not do that. I would have to count the probability of two heads, three heads, four heads, five heads, six heads, seven heads, eight heads, nine heads, 10 heads, when instead I could just calculate the probability of zero heads and one head and then subtract that from one. Okay, I'll write this out. Probability of at least two is equal to 1 minus the probability of zero heads minus the probability of one head. Make sense? All right, so what's the probability of zero heads? That is going to be 1 over 2 to the 10th. The reason is because there's only one possible outcome. There's only one way to get zero heads, and that's by getting all tails. There's no other way of getting that. And of course, there are 2 to the 10 total possible outcomes because, right, we have 10 flips, and each one of them can be one of two options. What's the probability of one head? That's going to be 10 over 2 to the 10th. Now, the reason for that is because we're essentially asking ourselves, how many ways can we get one head? So that's H, T, 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 T. And how many ways can we order that? That is just going to be 10 because there are 10 possible places to place the head down. In other words, how many ways can we order the word H, T, 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 T? It's going to be 10 factorial over 9 factorial because the t's are repeated 9 times, which is 10, right? So that's the idea there. So that means my answer is going to be 1 minus the probability of zero heads, which is 1 over 2 to the 10, minus the probability of one head, which is 10 over 2 to the 10th. You could also simplify this, right? This is 1013 divided by 1024. Okay, last question. It's getting late. Time for bed. You flip a coin 6 times. Calculate the probability that at least one of the flips yielded the same result as the one right before it. Wow, that is some confusing wording. But I do remember what I was trying to say here when I wrote this question. Calculate the probability that at least one of the flips yielded the same result as the one right before it. So here's what I'm thinking. H, T, H, T, H. For this sequence, did at least one of the flips yield the same result as the one right before it? The answer is no, right? All of them are different. Or what I mean is that each one is totally different than the one, than the one that came right before it. However, maybe there's something like H, T, 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 H, T. Right? Here, in this case, the T here is the same result as the one that came right before it. So that would work. So once again, here, complementary counting is going to be our friend because it's much easier to count all the cases where no flips yielded the same result as the one right before it. So let's calculate 1 minus the probability of no flip yielding the same as the one right before. Okay, so what is that probability? That is going to be 2 over 64. Now you might be asking me, how in the world did I get 2 over 64? Well, you just think about the number of possible desired outcomes over the number of possible outcomes. Okay, so possible outcomes, that's pretty straightforward. We have six flips, and each flip could go one of two ways. So that comes out to 2 to the 6 possible outcomes. But how many desired outcomes are there? How many ways are there for me to get no flip yielding the same as the one right before? If you just think about it, it's just going to be two ways, right? Because if I start with a head, that means the next one has to be a tail, which means it has to be head next, tail, head, tail. Whereas if I start with a tail, I'm forced to get a head on the next one, and a tail on the next one, then a head, then a tail, and then a head. And that's the only two possibilities. That's why it's 2 over 64. All right, so here we see the probability or the power of complementary probability and complementary counting. Well, that was a little challenging, I do admit. I haven't written the test yet, but let's hope that I'll be a little more merciful when I'm writing the test. But I hope this was helpful, and I'll also try to write another practice test for you guys all to work on.